Imagine being 25,000 feet above the European continent in the dead of winter. The temperature outside the thin aluminum skin of your aircraft is 60 degrees below 0 Fahrenheit. You are encased in a heavy sheepskin flight suit, plugged into an electrical heating system that might short out and burn you, or fail entirely and leave you to lose fingers to frostbite. You are breathing through a rubber oxygen mask that, if it freezes with the condensation of your own breath, will kill you from anoxia in less than 3 minutes. You are wedged inside a Sperry ball turret, a glass and metal sphere hanging from the belly of a B-17 flying fortress, staring down at hostile territory. Now, factor in that hundreds of enemy fighter planes, armed with heavy cannons, are vectoring toward your exact location, and the air around you is about to be filled with the black, jagged bursts of 88mm anti-aircraft artillery. This was not an occasional nightmare. This was the daily reality for the young American men of the United States Army Air Force's 8th Air Force. Statistically speaking, in the autumn of 1943, an American bomber crewman, flying daylight missions over Germany, had a higher chance of being killed or captured than a United States Marine, hitting the beaches in the Pacific Theater. It was a slaughterhouse in the stratosphere. Welcome back to the channel. If you want to understand the brutal, unvarnished truth of military history, the tactics that won wars, and the sheer human cost of industrial combat, hit that subscribe button right now. We do not gloss over the harsh realities here, and your support allows us to keep digging deep into the archives. Make sure you hit the notification bell so you never miss a briefing. To understand how the United States found itself locked in this high-altitude meat grinder, we have to strip away the mythology and look at the cold, hard strategic context. The roots of this aerial bloodbath were planted decades before the first bomb dropped on Germany. Following the end of the First World War, military theorists around the globe looked at the stagnant, muddy trenches of the Western Front and vowed to never repeat that slaughter. Men like Giulio Douhet in Italy, Hugh Trenchard in Britain, and Billy Mitchell in the United States began to formulate a radical new doctrine. They believed that the airplane had fundamentally changed the nature of warfare. The theory was intoxicating in its simplicity. Why fight your way through millions of entrenched infantrymen when you could simply fly over them? The doctrine of strategic bombing was born out of the belief that heavy bombers, flying in mass formations, could bypass the front lines and strike directly at the enemy's industrial heart, their factories, their steel mills, their rail yards, and the very will of their civilian population. At the Air Corps Tactical School at Maxwell Field in Alabama during the 1930s, a group of American officers who would become known as the Bomber Mafia refined this theory into a uniquely American doctrine. They developed the industrial web theory. They posited that a modern industrialized nation was like a spider web, and if you destroyed a few critical nodes, ball-bearing plants, oil refineries, aircraft engine factories, the entire web would collapse. Furthermore, they believed in daylight precision bombing. Unlike the British, who would eventually resort to nighttime area bombing due to heavy losses. The Americans believed their technology would allow them to drop bombs with pinpoint accuracy from high altitudes in broad daylight. They also held a fatalistic, almost arrogant belief that would cost thousands of lives. They believed that the heavy bomber, bristling with defensive machine guns and flying in tight formations, was invincible. The prevailing maxim of the era, coined by British Prime Minister Stanley Baldwin, was that the bomber will always get through. They did not believe long-range escort fighters were necessary, nor did they think it was technologically feasible to build a fighter with the range of a heavy bomber without sacrificing all of its combat performance. Did the brass really believe unescorted bombers could shoot their way through the most heavily defended airspace on Earth? The tragic answer is yes, they did. And they committed to this doctrine with religious fervour. We can compare this dogmatic belief to the French infantry doctrine of 1914, where commanders believed that sheer offensive spirit and the bayonet could overcome modern heavy machine guns. Or, for an American context, think of Pickett's charge at Gettysburg, where Robert E. Lee believed that massed infantry could march across an open field and break a fortified defensive line through sheer courage and numbers. The American bomber generals believed their defensive firepower was an impenetrable shield. They were about to be violently disabused of this notion. The strategic imperative came to a head in January 1943 at the Casablanca Conference. President Franklin D. Roosevelt and Prime Minister Winston Churchill met to chart the course for the defeat of the Axis powers. The British were highly skeptical of the American daylight bombing plan. Churchill wanted the Americans to join the Royal Air Force in night bombing, creating a round-the-clock terror campaign against German cities. But Major General Ira Eaker, commanding the 8th Air Force, managed to convince Churchill to allow the Americans to continue their daylight precision campaign. The result of this conference was the Casablanca Directive, which authorized the combined bomber offensive. The objective was the progressive destruction and dislocation of the German military, industrial and economic system, and the undermining of the morale of the German people to a point where their capacity for armed resistance is fatally weakened. But there was a massive, lethal obstacle standing in the way of this grand strategy: the German Luftwaffe. By mid-1943, the Allied planners realized a terrifying truth. Operation Overlord, the planned invasion of France, could not happen, would not happen, if the Luftwaffe still existed as a viable fighting force. If German bombers and fighters could attack the invasion beaches, the Allied fleets and the landing troops would be annihilated. General Dwight D. Eisenhower made it absolutely clear that air supremacy over the English Channel and northern France was a non-negotiable prerequisite for D-Day. Therefore, the strategic bombing campaign had to pivot. Before they could destroy the German economy, they had to destroy the German Air Force. This new, highly focused mission was given the code name Operation Pointblank. Operation Pointblank was not just a series of raids. It was a mandate for a war of extermination in the sky. The primary directive was to attack the German aircraft industry, specifically the factories producing single-engine fighters, and to force the Luftwaffe into the air, where it could be destroyed in a war of attrition. To execute this colossal undertaking, we must examine the tools of war, the forces arrayed against each other, and the immense industrial logistics required to sustain such a campaign. Let us start with the American side of the equation, the heavy bombers of the 8th Air Force. The backbone of the American daylight bombing campaign was the Boeing B-17 Flying Fortress and the consolidated B-24 Liberator. The B-17 is arguably the most famous bomber in history, and for good reason. It was a rugged four-engine behemoth powered by Wright R-1820 Cyclone radial engines, each producing 1,200 horsepower. The B-17F, the primary variant used in the early stages of Pointblank, could carry a bomb load of roughly 4,000 to 5,000 pounds for long-range missions over Germany. But its true defining characteristic was its defensive armament. The Flying Fortress was designed to be exactly that, a fortress. It bristled with up to 13 Browning M2 50 caliber machine guns. The 50 caliber Browning was a devastating weapon, firing a heavy, armor-piercing incendiary tracer round at a muzzle velocity of 2,900 feet per second. It could punch through the engine blocks and armor glass of German fighters at ranges exceeding 1,000 yards. To maximize this firepower, American tacticians developed the combat box formation. A combat box consisted of a group of bombers, usually 18 to 21 aircraft, arranged in a staggered, three-dimensional formation. There was a lead squadron, a high squadron, and a low squadron. This staggering allowed the gunners in each bomber to have clear fields of fire without hitting their own wingmen. The theory was that a combat box would create an interlocking sphere of 50 caliber crossfire so dense that no enemy fighter could penetrate it without being shredded. The B-24 Liberator, while less glamorous than the B-17, was actually produced in greater numbers and carried a heavier bomb load over a longer range. It featured the highly efficient Davis wing, a high aspect ratio wing that gave it excellent cruising speed and range. However, the B-24 was notoriously more difficult to fly, more prone to catastrophic fires when hit, and its flat-sided fuselage earned it the grim nickname of the Flying Boxcar. Together, these two aircraft formed the blunt instrument of American strategic will. At the heart of the American precision bombing doctrine was a piece of technology so highly classified that bombardiers had to swear an oath to defend it with their lives, the Norden bombsight. This was an early analog computer, a complex arrangement of gyroscopes, gears, and optical lenses. The bombardier would input the aircraft's airspeed, altitude, and wind drift. The bombsight would calculate the exact trajectory required for the bomb to hit the target. In the final moments of the bomb run, the bombsight actually took control of the aircraft via the automatic flight control equipment, flying the plane perfectly level to ensure a stable drop. American propaganda claimed the Norden bombsight could drop a bomb into a pickle barrel from 20,000 feet. The reality was vastly different. In the clear, unclouded skies of the American Southwest where it was tested, it was highly accurate. But over the industrial heartland of Germany, obscured by persistent cloud cover, industrial smog, and the smoke of battle, the accuracy degraded significantly. Often, if the lead bombardier missed, the entire formation which dropped on his signal missed as well. The logistics required to put these armadas into the air were staggering. It was an industrial mobilization unlike anything seen in human history. To understand the scale, compare it to the American production of Liberty ships, or the arsenal of democracy that armed the Soviet Union. The United States was essentially building a new air force every few months. At the Ford Motor Company's massive Willow Run plant in Michigan, utilizing automotive assembly line techniques, they were eventually rolling a B-24 Liberator off the line every 63 minutes. To sustain the 8th Air Force in England, the United States had to ship millions of gallons of 100-octane aviation fuel across the U-boat-infested Atlantic. They had to ship millions of tons of 500-pound general-purpose bombs, replacement engines, aluminum sheeting, and the crews to man them. The eastern counties of England, particularly East Anglia, were transformed into one massive, sprawling airfield. It was said that if they poured any more concrete in East Anglia, the island would sink into the sea. Now let us look at the enemy. The men of the 8th Air Force were not flying into an empty sky. They were flying into the teeth of the most sophisticated, battle-hardened, and technologically advanced air defense system on the planet. The Luftwaffe, specifically the Jagdwaffe, the fighter force, was commanded by men like Adolf Galland, a brilliant tactician and a ruthless fighter pilot. The German air defense was not a static line. It was a dynamic, integrated system of radar, anti-aircraft artillery, and interceptor aircraft. The primary interceptors of the Luftwaffe were the Messerschmitt Bf 109 and the Focke-Wulf Fw 190. The Bf 109, particularly the G series known as the Gustav, was a lightweight, highly maneuverable fighter powered by a Daimler-Benz inverted V12 engine. It was a proven killer, having honed its deadly trade over the skies of Spain, France, and the Soviet Union. But the true butcher of the American bomber formations was the Focke-Wulf Fw 190, designed by the brilliant engineer Kurt Tank. The Fw 190 was a brutal, rugged machine powered by a massive BMW 801 radial engine. It was heavily armored, protecting the pilot from the American .50 caliber defensive fire, and it carried an absolutely devastating armament. While the Americans relied on the volume of fire from .50 caliber machine guns, the Germans relied on the explosive power of heavy cannons. The Fw 190 was typically armed with two 13mm machine guns and four 20mm MG 151 cannons. The Germans had developed a specific type of ammunition for these cannons called the Minengeschoss, or mine shell. Instead of a solid armor-piercing slug, the mine shell was a thin-walled projectile filled with high explosive. When it struck the aluminum skin of a B-17, it did not just punch a hole. It detonated, tearing massive, jagged panels of metal away, destroying control cables and shattering the structural integrity of the wing spars. German testing concluded that it took an average of 20 hits from a 20mm cannon to destroy a heavy bomber. A skilled FW-190 pilot could deliver that in a single 2-second burst. How do you break a defensive system that is deeply entrenched, highly motivated, and technologically equal? You don't finesse it. You grind it to dust through sheer industrial attrition. The American planners knew they were sending young men into a meat grinder. The strategy was brutally simple, reminiscent of Ulysses S. Grant's Overland Campaign in 1864. Grant knew the Army of the Potomac would suffer horrific casualty against Robert E. Lee's Army of Northern Virginia in the wilderness and at Cold Harbor. But Grant also knew he had the industrial and demographic backing to replace his losses, while Lee did not. Operation Pointblank was the aerial equivalent of the Overland Campaign. General Karl Spaatz and General Ira Eaker were going to push their bomber formations deep into Germany, knowing full well that they would take massive losses. The goal was to force the Luftwaffe to rise up and defend their factories. The bombers were the bait, and the objective was the slow, bloody, mathematical destruction of the German fighter force. The German defensive tactics evolved rapidly to counter the American combat boxes. Early in the war, German fighters attacked from the rear, sliding in behind the bombers. But they quickly realized that this exposed them to the concentrated fire of the tail, waist, and ball turret gunners. Furthermore, the closing speed from the rear was slow, meaning the German fighter had to endure American fire for a longer period. A German fighter pilot named Egon Meyer is credited with pioneering a terrifying new tactic: the head-on attack. The Germans realized that the nose of the B-17F was relatively weakly defended, usually armed with only a few flexible machine guns operated by the bombardier and navigator. More importantly, a head-on attack maximized closing speed. A B-17 cruising at 200 miles per hour and a FW-190 attacking head-on at 400 miles per hour resulted in a closing speed of 600 miles per hour. This meant the German pilot had roughly 2 seconds to aim, fire his cannons, and violently dive away to avoid a mid-air collision. For the American bomber crews, it was a paralyzing experience. They would see a speck in the distance, and seconds later, a heavily armored Focke-Wulf would be flashing past their cockpit, its wings winking with the flash of 20mm cannons, the cockpit glass shattering, and the smell of cordite filling the frozen air. Beyond the fighters, the American crews had to survive the flak. The German anti-aircraft artillery network was massive and lethal. The backbone of this system was the infamous 88mm Flak 36, originally designed as an anti-aircraft gun, but famous for its use as a tank killer. Over the cities of the Reich, the 88s, along with heavier 105mm and 128mm guns, were massed in massive batteries. These were not random potshots. The German flak was controlled by sophisticated radar and optical rangefinders. They fired time-fused shells designed to detonate at the exact altitude of the bomber formations. a single 88mm shell bursting through jagged, razor-sharp steel shrapnel in a lethal radius. The flak was so thick over targets like the Ruhr Valley, known to the bomber crews as Happy Valley, that pilots claimed you could get out and walk on it. The flak did not just destroy bombers outright. It damaged engines, forcing bombers to drop out of formation. A bomber that lost an engine and fell behind the combat box was called a straggler, and in the freezing skies over Germany, a straggler was a dead man walking, immediately pounced upon by packs of prowling German fighters. The entire German defense was orchestrated by the Kammhuber Line, a sophisticated air defense network stretching from Denmark to central France, using long-range Freya radar to detect incoming formations and short-range Würzburg radar to track individual aircraft. German ground controllers could vector their fighter squadrons, known as Jagdgeschwader, to intercept the American bombers with devastating precision. The Americans were flying blind into a technologically advanced, fully integrated kill zone. By the summer of 1943, the pieces were set on the board. The American industrial machine was pumping out bombers and crews at a staggering rate, filling the airfields of England. The Luftwaffe had concentrated its veteran fighter wings, pulled from the Eastern Front and the Mediterranean, to defend the airspace of the fatherland. The doctrine of unescorted daylight precision bombing was about to face its ultimate trial by fire. General Eaker and the planners at the 8th Air Force looked at the maps, drew lines deep into hostile territory, toward targets like the ball-bearing plants at Schweinfurt and the aircraft factories at Regensburg, and prepared to send their men into the abyss. The theory had been debated in the classrooms of the Air Corps Tactical School. Now, it was time to test it in the freezing, blood-soaked skies over Europe, where the cost of being wrong would be measured in thousands of burning aircraft and the lives of a generation. The air war over Europe in the summer of 1943 became a ruthless laboratory for industrial slaughter. The American bomber crews were not just fighting the Luftwaffe. They were fighting the environment itself. At 25,000 feet, the ambient temperature plummeted to 60 degrees below 0 Fahrenheit. The heavy bombers were unpressurized and unheated, essentially flying aluminum iceboxes. To survive, crews wore the F-2 electrically heated flight suit, a bulky garment wired with heating coils. But the technology was primitive. If a waist gunner knelt on a wire and broke the circuit, he could lose his legs to frostbite in minutes. If the system short-circuited, it could literally ignite, setting the crewman on fire in the freezing oxygen-rich environment. To protect against the lethal storm of flak and 20mm cannon shells, Colonel Malcolm Grow, the chief surgeon of the 8th Air Force, developed the flak suit. This was a heavy canvas vest lined with overlapping plates of manganese steel, weighing nearly 30 pounds. It offered some protection against low-velocity shrapnel, but it made moving around the cramped, freezing fuselage of a B-17 physically exhausting. These young men, many barely out of high school, were fighting a war of attrition, clad in the armor of medieval knights, operating the most advanced machinery of the 20th century. To counter the devastating head-on attacks pioneered by German pilots, American engineers scrambled for a technological fix. The result was the B-17G, the definitive model of the flying fortress. The most prominent feature of the G model was the Bendix chin turret, a motorized, remote-controlled blister under the nose housing twin 50 caliber machine guns. The bombardier operated this turret using a complex yoke sight, providing massive forward-facing firepower. The theory was that the Bendix turret would shred any Focke-Wulf attempting a head-on pass. But did this solve the problem? The brutal reality of aerial combat is that the enemy always adapts. German pilots simply adjusted their attack vectors, coming in from slightly higher or lower angles, or executing sweeping high-speed slashing attacks that gave the American gunners only a fraction of a second to track them. The bombers were still taking horrific losses. The fundamental flaw in the American doctrine was the lack of a long-range escort fighter. The primary American fighter in the European theater at this time was the Republic P-47 Thunderbolt, affectionately and fearfully known as the Jug. The P-47 was a monster of an aircraft, weighing in at over 7 tons fully loaded. It was built around the massive Pratt & Whitney R2800 double Wasp radial engine, a supercharged beast generating 2,000 horsepower. Armed with 850 caliber machine guns, the Thunderbolt was a flying tank that could outdive anything in the sky. When a P-47 pilot pushed the nose down, gravity and 7 tons of metal turned the aircraft into a meteor. This diving tactic was highly effective against the lighter German Messerschmitts. We can compare the shock effect of a diving P-47 squadron to the devastating heavy cavalry charges of the American Civil War, where commanders like Philip Sheridan used mass and momentum to shatter enemy lines. But the Thunderbolt had a fatal Achilles heel. It had incredibly short legs. On internal fuel alone, the P-47 had a combat radius of barely 200 miles. This created a terrifying geographical reality for the bomber crews. The P-47s could escort the bombers across the English Channel, over the coast of occupied Europe, and as far inland as the German border near Aachen. But at that precise point, the fighter pilots would have to waggle their wings in a heartbreaking salute and turn back for England, or risk ditching in the freezing Channel out of fuel. The German fighter controllers knew this exact limit. They called it the fighter line. The Luftwaffe would mass their squadrons just beyond this invisible boundary, waiting patiently. Crossing the fighter line without escort was like an American pioneer wagon train, crossing the Missouri River into hostile Comanche territory in the 1860s. Once you left the protective umbrella of the cavalry forts, you were entirely on your own against a highly mobile, lethal enemy that knew the terrain perfectly. The climax of this flawed doctrine arrived in the late summer and autumn of 1943, a period that would permanently scar the United States Army Air Forces. The planners at the 8th Air Force decided to launch a massive, complex double strike deep into the heart of the German aviation industry. The date was August 17, 1943. The targets were the massive Ball, bearing factories at Schweinfurt and the Messerschmitt fighter production plants at Regensburg. The strategic logic was sound. Ball bearings were the frictionless lifeblood of the German war machine, required in everything from aircraft engines to U-boat periscopes. Destroy the bearings, and the machine grinds to a halt. The tactical plan was incredibly ambitious. General Curtis LeMay would lead the first strike force of 146 B-17s against Regensburg. To confuse the German defenders, LeMay's force would not return to England. Instead, they would fly south, cross the Alps, traverse the Mediterranean, and land at bases in North Africa. 10 minutes behind LeMay, a second force of 230 B-17s, commanded by Brigadier General Robert Williams, would strike Schweinfurt and return to England. The planners hoped that LeMay's force would draw the entire Luftwaffe fighter reserve into the air. By the time Williams arrived over Schweinfurt, the German fighters would be on the ground, refueling and rearming, leaving the skies clear. It was a brilliantly conceived plan that fell apart before the first bomb was dropped. On the morning of August 17th, thick, impenetrable fog blanketed the airfields of East Anglia. LeMay's Regensburg force, operating from bases where the fog was slightly thinner, managed to take off after a grueling delay. But Williams's Schweinfurt force was grounded. The critical 10-minute gap between the two armadas stretched into 3 agonizing hours. The trap was sprung, but only half the American force was in it. As LeMay's unescorted bombers crossed into Germany, the Luftwaffe descended upon them with apocalyptic fury. The German controllers vectored over 300 fighters against the Regensburg force. This was not a quick skirmish. It was a running, 2-hour bloodbath. The Germans introduced a terrifying new weapon that day: twin-engine Messerschmitt Bf-110s and Junkers Ju-88s, normally too slow to survive in daylight combat, parked themselves a mile behind the American formations, well out of range of the .50 caliber defensive fire. From this safe distance, they unleashed the Werfer Granat 21, massive 21-centimeter air-to-air rockets. How do you defend against an enemy that can lob heavy artillery shells into your formation from beyond the range of your own guns? You cannot. The rockets tore through the combat boxes, shattering formations and scattering bombers. Once a B-17 was separated from the mutually supporting fire of the box, the single-engine Focke-Wulfs swarmed it like sharks smelling blood in the water. LeMay lost 24 bombers before he even reached Regensburg. They bombed the target accurately, but the cost was staggering. As they turned south toward the Alps, their ordeal was not over. They were attacked by fighters from Austria and Italy, and many severely damaged bombers, their engines failing and their airframes riddled with holes, could not climb over the jagged alpine peaks. They crashed into the ice or ditched in the Mediterranean. 3 hours later, the fog in England finally lifted, and the Schweinfurt force launched. By this time, the German fighters that had mauled LeMay had landed, refueled, rearmed with fresh cannon shells, and were climbing back to altitude. The Schweinfurt force flew directly into a fully primed, battle-hardened meat grinder. The Luftwaffe shot down 36 bombers from the Schweinfurt force. In a single day, the 8th Air Force lost 60 heavy bombers. 600 young American men were killed, captured, or missing. Countless other aircraft limped back to England, so heavily damaged they had to be scrapped. It was a casualty rate of nearly 20%. Did the American commanders halt the offensive to rethink their strategy? The harsh reality of high command is that momentum often overrides caution. General Ira Eaker believed they had inflicted crippling damage on the German industry. He believed the Luftwaffe was bleeding just as heavily. He was wrong. The German industrial minister, Albert Speer, rapidly dispersed the ball-bearing machinery, and production barely dipped. The Luftwaffe, fighting over their own territory, was recovering their bailed-out pilots and putting them back in the cockpit the next day. The Americans were replacing their losses with green crews straight out of flight school in Texas, throwing them directly into the most unforgiving combat environment on Earth. This stubborn adherence to a failing doctrine culminated on October 14th, 1943, a day forever etched in American military history as Black Thursday. The target was once again the ball-bearing plants at Schweinfurt. 291 B-17s crossed the enemy coast. This time the Luftwaffe did not just attack. They orchestrated a symphony of destruction. German radar tracked the bomber stream from the moment it left England. They marshaled fighters from all over Germany, holding them in massive formations. As soon as the American P-47 escorts hit their fuel limits and turned back, the slaughter commenced. Wave after wave of Focke-Wulfs and Messerschmitts tore into the bomber stream. They attacked in trail formations of up to 6 aircraft, flying straight through the American combat boxes, holding their triggers down, and filling the air with explosive mine shells. Entire squadrons of American bombers were wiped out in minutes. The sky over Germany was littered with burning aluminum, spinning propellers, and the white blooms of parachutes. The 305th Bomb Group lost 13 of its 15 aircraft. Of the 291 bombers dispatched, 60 were shot down over Europe. 17 more crashed in England or were damaged beyond repair. 121 returned with severe battle damage. Over 600 men were lost in a matter of hours. The losses on Black Thursday were proportional to the catastrophic casualties suffered by the 1st Marine Division during the amphibious assault on Peleliu. It was an unsustainable, catastrophic bleed of American youth and industrial capital. The doctrine of the unescorted daylight bomber had not just failed. It had been violently, undeniably shattered. The 8th Air Force was broken. For the rest of 1943, American heavy bombers were restricted to targets in France and the coastal areas, entirely within the protective radius of their short-legged fighter escorts. Deep penetration raids into Germany were suspended. The Luftwaffe had won the first round. Operation Pointblank was on the verge of total collapse. General Henry Hap Arnold, the commanding general of the Army Air Forces back in Washington, was furious. The entire justification for an independent air force rested on the promise of strategic bombing, and that promise was currently burning in the fields of Bavaria. The American High Command faced a desperate crisis. They had the bombers, they had the production lines, and they had the raw courage of the crews, but without a way to protect them all the way to the target and back. The air war over Europe was lost. The planned invasion of France, Operation Overlord, hung in the balance. If they could not break the back of the Luftwaffe, the infantry would never make it off the beaches of Normandy. They needed a technological miracle, and they needed a ruthless shift in tactical philosophy. They needed an aircraft that could fly to Berlin and back, and they needed commanders who were willing to unleash those fighters, not just to shield the bombers, but to hunt the hunters. The miracle came in the form of a bastard child of American engineering and British propulsion. The North American P-51 Mustang was initially designed in a rapid 120 days to meet a British purchasing commission requirement. It featured a revolutionary laminar flow wing, pushing the thickest part of the wing further back to dramatically reduce aerodynamic drag. But the original American Allison V1710 engine choked and gasped for air above 15,000 feet, rendering it useless for high-altitude bomber escort. The stroke of absolute genius was mating this sleek, low-drag airframe to the supercharged Rolls-Royce Merlin engine, built under license in Detroit by the Packard Motor Car Company as the V1650. Suddenly, the Mustang had the high-altitude performance to match and even exceed the Focke-Wulfs and Messerschmitts. But how do you get a fighter plane all the way to Berlin and back? The answer was deceptively simple plumbing. The engineers introduced drop tanks. These were compressed paper or aluminum tanks carrying 75 to 108 gallons of aviation fuel, strapped under the wings and jettisoned when empty. Add an internal 85-gallon fuel tank behind the pilot's armor plating, and the Mustang's combat radius exploded to over 800 miles. It could escort the heavy bombers to the deepest, most heavily defended targets in the Third Reich, fight at full throttle for 20 minutes over the target, and fly home. We can compare this sudden, radical extension of lethal reach to the introduction of the intercontinental ballistic missile during the Cold War. It fundamentally altered the strategic geography of the conflict, meaning the sanctuary of the German interior was gone forever. But technology alone does not win wars, as it requires a ruthless mind to employ it effectively. In January 1944, Major General Jimmy Doolittle, the legendary pilot who led the Tokyo raid, took command of the 8th Air Force. Doolittle looked at the standing orders for his fighter pilots, which dictated they must stay tightly tethered to the bomber formations, acting as a defensive shield. Doolittle recognized the inherent flaw in this logic, realizing that passive defense against a highly mobile enemy is a recipe for slow defeat. Why surrender the initiative to the enemy? He famously walked into a fighter group headquarters and saw a sign on the wall that read, "Our job is to protect the bombers." Doolittle ordered it taken down immediately, and replaced with a new, aggressive mandate, stating that their job was to destroy the Luftwaffe. He unleashed the Mustangs, the heavy P-47 Thunderbolts and the twin-engine P-38 Lightnings. No longer were they tied to the slow-moving combat boxers. They were ordered to sweep hundreds of miles ahead of the bomber streams, dive on German airfields, and hunt the Luftwaffe down wherever they could be found. This aggressive shift is directly parallel to the evolution of anti-submarine warfare in the Battle of the Atlantic. When the Allies stopped merely escorting convoys and started forming independent hunter-killer naval task forces to actively track down U-boats, the tide of the naval war turned. Doolittle turned his fighter squadrons into airborne hunter-killer groups. The ultimate test of this new paradigm arrived in late February 1944, during a rare period of uncharacteristically clear winter weather over Central Europe. The operation was officially designated Operation Argument, but history remembers it simply as Big Week. For 6 consecutive days, the United States Army Air Forces launched maximum effort raids, putting over 1,000 heavy bombers and 800 escort fighters into the air simultaneously. The visual scale of this armada was staggering, with the condensation trails of nearly 2,000 aircraft turning the freezing stratosphere into a solid white overcast. The designated targets were the massive aircraft assembly plants at Leipzig, Regensburg, and Augsburg. But the real target was the German fighter force itself. The Luftwaffe commanders, seeing their industrial base under systematic annihilation, had no choice but to throw every available fighter into the sky to defend it. It was exactly what Doolittle and the American planners wanted. How does a defending force survive when the enemy uses their own vital organs as bait? The brutal answer is they do not. The skies over Germany turned into a swirling, chaotic, three-dimensional meat grinder. The P-51 Mustangs, arriving in massive numbers, engaged the heavy, twin-engine German rocket carriers that had caused such devastation the previous autumn and slaughtered them mercilessly. When the single-engine Focke-Wulfs and Messerschmitts dove on the bombers, the Mustangs were waiting, dropping their external tanks and utilizing their superior high-altitude maneuverability to tear inside the German fighters. The 50 caliber machine guns of the American fighters tore through the unarmored engine blocks of the Messerschmitts, sending them plunging into the Bavarian countryside. To truly grasp the annihilation of the Luftwaffe during Operation Pointblank, we must step out of the cockpit and look at the brutal mathematics of industrial warfare and military intelligence. Through the highly classified Ultra-Intelligence Program, which decrypted the highest-level German Enigma communications, Allied planners knew exactly how badly the Germans were bleeding. The paradox of the German war economy in 1944, under the brilliant but ruthless direction of Albert Speer, was that they were actually producing more fighter aircraft than ever before. German factories, dispersed into forests and underground bunkers, churned out nearly 40,000 aircraft in 1944, But an airplane without high-octane fuel or a trained pilot is just an expensive piece of static aluminum. The simultaneous American bombing campaign against the synthetic oil plants at Luna and the massive refineries at Ploesti was starving the Reich of aviation gas. This logistical strangulation is highly reminiscent of the Union naval blockade of the Confederacy during the American Civil War. The South had the cotton and the will to fight, but the Anaconda Plan slowly choked off their ability to move supplies and wage modern war. The 8th Air Force was executing an aerial Anaconda Plan, cutting the fuel lines of the German war machine. Because of this catastrophic fuel crisis, the German pilot training pipeline completely collapsed. American pilots arriving in England had over 300 hours of flight time, including extensive aerial gunnery, navigation, and instrument training in safe skies over Texas and Florida. By mid-1944, the Luftwaffe was throwing teenager into the cockpits of high-performance FW-190s with barely 50 hours of total flight time and almost no live-fire combat gunnery practice. They were sending novices to fight battle-hardened veterans. The attrition rate among German squadron commanders, the irreplaceable experts who held the Luftwaffe together through sheer experience, skyrocketed. Men who had survived the Battle of Britain and the freezing hell of the Eastern Front were being ground down by the sheer relentless volume of American firepower. By April and May of 1944, the dynamic in the sky had completely inverted. The American fighter sweeps were no longer just fighting at 25,000 feet. They were dropping down to the deck, strafing German airfields, shooting up locomotives, and destroying the Luftwaffe on the ground before the German pilots could even start their engines. The dreaded fighter line that had terrified American bomber crews just months prior had been pushed all the way to Berlin, and then erased entirely. Operation Pointblank achieved its grim, bloody objective. When the Allied landing craft dropped their ramps on the beaches of Normandy on June 6, 1944, the skies above them were entirely dominated by Allied aircraft. The Luftwaffe bled white over the skies of the Reich, could barely mount a token resistance against the invasion fleet. Operation Pointblank was not a clean, surgical campaign. It was a brutal, blunt force trauma inflicted on an industrial scale. It cost the United States Army Air Forces over 26,000 dead, a staggering toll that exceeded the combat deaths of the entire United States Marine Corps during the Second World War. The initial doctrine of unescorted daylight precision bombing was a deeply flawed theory paid for in the blood of young Americans. It was only redeemed by the miraculous technological intervention of the long-range escort fighter and the ruthless, tactical pragmatism of commanders who understood that you do not win wars by defending. You win by destroying the enemy's capacity to fight. War is an unforgiving auditor, balancing its ledgers not in dollars, but in blood, steel, and the cold reality of industrial output. Before you go, let us test your strategic mindset. Which factor do you believe was the most critical in the ultimate success of Operation Pointblank? A. The technological leap of the P-51 Mustang. B. General Doolittle's tactical shift to offensive fighter sweeps. C. The logistical strangulation of the German fuel supply. Drop your answer, A, B, or C, in the comments below, and defend your position.